Hello everyone. Quick episode of Yo at Home. Just wanting to show why the constellations change through the year and how we orbit the sun. So here's the sun and here is Earth orbiting it. Now that would take 1 year. If we think about that, the number of degrees in that circle is 360 degrees. If we divide that by 365 days to go around that circle once, we have about 1 degree per day in our orbit around the sun. So why do we have different constellations? If we think of the Earth here, this is the nighttime sky you're looking at, and in the autumn, these are the constellations you would see. Just some basic autumn constellations, and of course you could see these in the other times of the year too, or in the winter and the summer, just in the evening or the morning. But in general, you have in the autumn Pegasus, Andromeda, Aquila, big constellations right overhead in the autumn. 3 months later, at midnight, we're pointing out this way. And the constellations we'd have overhead now are Orion, Taurus, Auriga, things like that, Gemini. 3 months after that, at night, we're looking this way. You realize the constellations you could see 6 months ago are out during the daytime now, so you couldn't see them at all. But at night now, you'd be seeing the spring constellations, Leo, Cancer, Gemini, things like that. 3 months after that, looking out this way, seeing the summer constellations, things like Corona Borealis, Hercules, Lyra, Cygnus, the Swan, constellations like that. So as we go around the sun in our orbit, we see different constellations all year long. Start keeping an eye out for them, and they become old friends after a while. The other thing this is worth pointing out too, as we're moving, if this is 1 day and in our orbit around the sun, this is the next day, if we were pointing directly at the sun here, if we're pointing at the same spot in the sky, we're no longer pointing at the sun because of our orbit around the sun. It's going to take us a little bit of extra rotation time to be pointing at the sun now. So it'll actually take 4 extra minutes of rotation so that we're pointing back towards the sun, right? We're not always having that same point. We need a little bit more rotation every day to be pointing at the sun again. So if we think about this, a solar day, the day from when the sun is at exactly one position in the sky to the next position in the sky, is defined as 24 hours. But a sidereal day, this is based on distant stars. And this is how we mark exactly where we're pointing. So a sidereal day is 23 hours and 56 minutes. It takes 23 hours and 56 minutes to point to the same spot in the sky. But it takes 24 hours if you want to point to the sun. That additional 4 minutes every day of extra rotation so we can continue pointing at the sun because we've moved 1 degree in our great orbit around the sun. That's all I have right now. Have a lovely day.